Hello, this is the differentiability YouTube video lesson. So differentiability is when there is a defined derivative at that point. And something you should note is that whenever solving differentiability, if it isn't continuous, then it isn't differentiable. But if it is differentiable, that means it is continuous. So some of the rules that you need to use when it comes to solving the equations or or whenever it comes to analyzing a graph are: 1, the point at x is equal to c is defined. 2, the point at x approaches c exists. 3, the limit and the y value at x is equal to c are equal. 4, the slope on the left approaches the slope on the right as x approaches c. So let's go to example 1, and this is just using an equation. So the question is the function differentiable at x is equal to 3? So we're given f of x, or this is a piecewise function, but we're given f of x, which is x squared. X is less than 3, 6x minus 9, and x is greater than or equal to 3. So the first step that we have is by first figuring out this kind of form. So we know that the limit is as x approaches 3 because of this, and we figured out 9 through plugging in 3 into each one of these equations. So 3 squared is 9. 6 times 3 is 18 minus 9, that's equal to 9. And since both of them are 9, we can write the limit of f of x as x approaches 3 is equal to 9. So now we can move on to step 2. Step 2 is basically what I just did, explaining it, but with all the work shown. And because both of these are equal to 9, we know that this is continuous, because both of these solutions are equal to the same, which means that it's continuous. That's what I wrote over here. So then now step 3 is to figure out whether it is differentiable or not. And the way I did this is the limit as x approaches 3, because that is the limit. So f of x minus f of 3 over x minus 3. So f of 3 we already said was, over here we said that f of 3 is 9. So I just crossed out 9, and here's how it would look like reworked. So now let's just plug in each equation into this template that I wrote out. So then the first one is x squared. So x squared minus 9 over x minus 3. So x squared minus 9 can be written as x plus 3 and x minus 3 over x minus 3. And since x minus 3 is in the numerator and x minus 3 is in the denominator, we can cancel them both out, and we will just have the limit as x approaches 3 from the left as x plus 3 is equal to 6. The way I did that is just by getting 3, plugging in it for x, 3 plus 3 equals 6. So now that we got the first equation from here, or like solution, now we need to use the second one. So I did the same process as the one I did before, but just plugged in 6x minus 9. But 6x minus 9, and then we already have minus 9 over here as well, or minus f of 3, which is 9. So if you have minus 9 and minus 9, you add them together, it's minus 18. So 6x minus 18 over x minus 3. You can simplify that, and you can get rid of, you can divide it by 6, so then you'll get 6 times x minus 3. Cancel out x minus 3 and x minus 3. So then you'll get 6 is that, and all that will be left is 6. So the answer is 6. And since the limit approaches 6 from the left and the right, it is both continuous and differentiable. So that is the solution for this example. So for example 2, this is using a graph. We need to figure out whether this graph is differentiable. So for these kind of questions, using these rules will really help out. So the point exists, the point at x is equal to 3 is defined. Yes, there's a point that's defined. The limit as x approaches c exists. Yes, this is approaching a value, this point, and this is also approaching this value. The limit and the y value at x equals 3, x is equal to c are equal. Yes, that is true. And the last one is the slope on the left approaches the slope on the right as x approaches c. So yes, the slope on the left is, the slope is -1, and this slope over here as it approaches from the left is also -1. This is as it approaches from the right. And since they both are the same, this graph is differentiable. So example 3 over here is using a graph as well, but this is just like an example of when it's not differentiable. So here's the graph. So just a couple. Okay, so let's go through the rules again. So the point at x is equal to c is defined. Yes, there are points. The limit as x approaches c exists. Yes, it does exist. The limit and the y value at x equals to c are equal. Yes, and the slope on the left approaches the slope on the right as x approaches c. So the slope on the left is -1, and the slope on the right is 1. -1 and 1 are not the same, so that's why I did x, which means that it's not differentiable. Thank you so much. Hope you have a great day.